Today we're going to be looking at SEER for manufacturing, that's SEER MFG, and all the elements belonging to SEER 3D, which work in parallel with SEER for manufacturing. Please have a look at the screen, have a look at the contact information relating to sales within America, outside of America, further information from Cassidy, the engagement specialist, and the website, and if you need support. So today we're going to be looking at SEER for manufacturing. So it's our 2D manufacturing solution. It's process rich. It's got many features and functions that allow you to build estimates from a PDF from scratch. It's also the costing engine for all of our SEER 3D solutions. So SEER 3D will read the step file from a CAD system and then interpret all of the surfaces, the faces, the features, and allow you to provide estimates that will be costed within SEER MFG for additive manufacturing, 3D printing, machining, CNC machining, milling, turning, and many other processes, sheet metal fabrication, castings, forgings, injection moldings, and again, other processes, and assembly processes, fit up, fasten, drill, and all of the normal processes you would expect within an assembly. So let's take a look at SEER 3D. So we'll start with a nice machined item. So this is the interface. Now all I have done is I've imported this step file. Again, you can manipulate it, you can look at it, you can explode the view if it's an assembly, you can do dimensional checks, etc. So we select from the available processes. In this case, we've got machining, additive, composite, sheet metal, node cast board. Select machining. We'll then come along and we'll decide what manufacturing environment we wish to use. Now, these are Excel workbooks and SEER for manufacturing knowledge bases that work together that control these environments. It's the limits, it's the tolerances, it's the setup times, it's the feeds and speeds and surface speeds and actual depth of cut, radial depth of cut, etc., to allow you to fine-tune SEER for 3D to reflect your processes, your efficiencies, your inefficiencies, and so on. So we can have a look at the environment. So there's a nice selection here. So this is a prismatic machining of the titanium forging, which this one is. Click on OK. The model will now just process all of the features. And then once that's done, we'll be able to go a little bit further. As you can see, we have a general tab, our roughing operations, surface finish, holes, countersinks, and DFM analysis. So each one of these will be populated by the system, and the environments will set these on your behalf. So it's set as a forging, it's set it as titanium. We can tell it the quantity. The batch size is set by the environment at 10%. You can change that to whatever we like. This is set. It's irregular because it's a forging, so the bounding box is kind of irrelevant in this area. Are we going to include deburring? Yes, we are. Do we want to include the forging? Yes, we will. Heat treatment operations, tool fab design, pocket analysis, etc. So we'll leave everything there. And this is just geometry features taken from the model based upon the geometry, the material type, and obviously the density. So for roughing, if this was made out of raw stock, this would be a rectangle, and we could decide we were going to skim the excess stock. We could cut away the external stock. We're going to cut away any internal stock. So if I just show you what it would look like if you wanted to cut away external stock, that's what it would do. It would cut this profile out to save you machining away the rectangular billet. So we don't want that because it's not relevant, because we have a forging. We're going to do some volume rough milling, detailed rough milling, some pocketing, and in the surface over here, we can have a look at the surfaces. You can select surfaces, you can deselect surfaces. So if you don't want to machine that one, you can turn it off. Likewise, you can turn all of these off, which is kind of important if you're starting from a casting where you're going to have faces that aren't machined. Holes and countersinks, we can have a look at these. So these are all going to be bored and drilled, so we can select one and see what it's saying. So it says it's a nominal tolerance. We can say it's going to be fine, which would change the tolerancing, and so on. So once that's done, we've also got DFM analysis now in the last release, so we can look on that one, run DFM analysis. You can take a look at what it's saying is possible. So it's identified some features. So this is a new feature which is growing, and it just gives you information relating to certain parts of the geometry which may be worth considering if you have the ability to do that. So let's come back. Let's go to the top. Let's click on estimate. And now from that, it's going to go off and create our estimate. So here we are. The model has run, 3D has run, and it's opened SEER for manufacturing. So we'll just quickly introduce you to SEER for manufacturing. So this is what it looks like. It has this 4-pane configuration. We have user inputs at the top, model outputs at the bottom, reports and charts which tabulate across the bottom. Each one of these steps are the process steps in manufacturing this part. Firstly, the forging, secondly, machining, and thirdly, any finishing that is required. For every one of these, we have a corresponding set of parameters. This is set general tab, process, tooling, inspection, rework, part, mark, and package. And on the general tab, which is common across all processes, we're talking about quantities, batch sizes, labor rates, capabilities of the people, classification of the part, which is where we decide whether this is an aerospace part or something more commercial. If we double click, you'll see the help is extensive. We have a 3-point input, at least, a likely, and a most. So we can start to capture uncertainty in the inputs. So the help's all here. So it's nice and simple to use, quick and easy and representative. And these are the sorts of things that the knowledge base are capturing for you, so you don't have to set these time and time again. Now, the 3-point estimate helps you set uncertainty. It's what Monte Carlo will use. And as you can see, we've got the likely, which is your most likely estimate, is people are going to be very high. Some may be extra high and some may be high. Now, this could be skilled men, superstars, less skilled people, semi-skilled people, apprentices, etc. So in reality, most production shops will have a range of capabilities. Not everybody's perfect, and we try to capture that within this type of input. And this is also a place where you can start to tune the machine to do your calibration. So that's set there. We can do step learning. In this case, we've just got a single step of 10,000 at the 95% curve, but you could continue down here entering multiple inputs. On the process specific tab, this is where we select the material. It's for forging, so we have no cost. That's covered in the forging operation. It's titanium alloys. Then this is all of the operations to produce this part. And you can see we got fees per tooth, actual depth of cut, radial depth of cut. And if I go view machining details, that will collapse all of them, so you can see each of the operations. We can look at the operation details, and we can see where the cost is being consumed. So the curve milled surfaces are time consuming. This pocket roughing is consuming a lot of time. So we could look at them and decide that's where we're going to focus our attention for our should cost, for our value engineering, for production engineering, etc. So lots of information to take in. We have a quick estimate, which is interactive. We can decide what we want to look at, quick estimate options. We can add other features here, click on OK. They appear in the list. And then we can set a reference, which is important. We can set 5 references in SEER, and we can start doing some what ifs. So we can say, what is the impact of not learning so quickly? Let's have ourselves another learning curve. So we'll say we're going to have, I don't know, 100 at 80. Click on OK, and we'll see the impact of that cost when it's calculated. So this is what's going on within the model itself. So this is SEER for manufacturing. And again, the reports and charts are all here to look at: cost contributions, operation analysis, operation details, material contribution, etc. The forging is over here. So these are different inputs relating to the volume of the part, the materials, the material cost per kilogram, setup stage, number of stages, and all of the things relative to that process. Whereas the bottom one is all about finishing, some abrasive blasting, solvent cleaning, and painting. So that's what SEER 3D does for you out of the box. Now, because you're now in the MFG solution, we can now add other work elements. We can do further operations, further processing, and you can see we do machining, fabrication, electrical assembly, assemblies, mold cast forgings, PCBs, fit up, fasten, drill, all those ones that say Pro were set up by the partners of the F-35 Lightning, the Joint Strike Fighter, and then more processes below it. So it's very process rich, and each one of those will ask you sensible engineering questions that you may need. So let's go back and look at another one. So this is a sheet metal part, obviously. Let's change that one to sheet metal. And again, we'll go through the process of selecting a manufacturing environment. We'll do simple brake press fittings, for example. Comes in with the default material. It lays it out flat. It evolves the shape. The shape complexity is calculated on your behalf based upon the features. So it identifies what the features are within the part, and compound bends, simple holes, cutouts, etc. And each one of these has a ranking and a scale. And based upon that, in the environment, it sets up this ranking scale. You can change it, but this is what it recommends it is based upon the INI file. Secondly, it's going to come along, we're going to do some abrasive water jet cutting. We don't have to. We can say we want to do laser beam cutting instead, and we can swap that over. But the idea is that you set your environments up for a given process, so that the skilled man can set this up with all of his knowledge and experience, and the less skilled operator, maybe somebody's not had as much production time, manufacturing time, can come along and with confidence use the correct environment and get himself a good cost, for herself a good cost accordingly. If we want to do any other processing in the background, we could say we want to do some epoxy priming, we want to do some metal bonding prep, and we'll do some what else will we do? Anything else if you want. Return tooling on. We're ready to go. Click on OK, and I just need to move this out the way. Click on estimate, and it will go off and start to create another estimate on our behalf. So here we go. This is the sheet metal part. So it's brought in the form operation, preform operation, and the sheet metal ops. So in the form, let's have a look. It's selected the material. It's doing what's the problem? Conventional machines. It's doing 6 brake press operations. In this one, it's doing the shearing of the part. It's doing the epoxy priming. It's doing the metal bonding prep, and so on. And then this one, a preform operation. This one's doing the laser beam cutting. So all of the operations are there, all covered by SEER 3D. So it also does assemblies. Now I'll just show you an assembly. This is the sorts of things we can handle, and bigger, and obviously. You can explode it. You can move this one around and have a look at the details of the parts. The idea is you basically come down through here, you allocate a process to each part. You can pick up the information relating to the assembly, the rivets, the fasteners, and all of them, which could be costed at the same time. But that's too big for today. So what I have is a nice simple brake press fit. This one here, this fitting here, and this is a brake caliper or connection of sorts. And what we'll do, we'll just go down through and show you what we need to do. So it's been selected as an assembly, a brake press fitting. Come down to the first one. It's a sheet metal part that's been selected. Its process has been selected, features, etc. Come down to the next one. These are fasteners, that one and that one. They're all done as well. The brake press is here. Again, another machined item. Same with this one. So again, with the machining, what are the roughing operations? What are the finishing operations? any holes or anything that needs to be done. In fact, we can go to that one and check. Yep, this one's already tapped. This one is another cap for the top, further machining, roughing operations are down here at the bottom, surface finish operations, and the holes. This one is another part. Let's just have a look at the shape. That's what it looks like within the assembly. And again, the features are counted here. General one, you have our brake press fitting environment selected, 2 more purchased parts, 2 pins, and then when we're ready to go, we click on estimate, and this will now produce us an estimate for this component. So here we are. This is the assembly as we know it. It's been brought in. You'll notice we've got things like global parameters here, which have been brought in by SEER 3D. All of the process steps have just changed the view to full length. So all the parts are listed down here, our fabricated parts, our machined parts. You can tell that quickly by these little emblems. This is machining. But the important one here is this one. So this is a different one. So this is part of the assembly process itself. It's brought in all the information, surface area, joint area, etc., associated with the assembly. The fit-up operations, we have 3 machined parts, 2 details, which are the fabricated parts. We're then going to do the fasteners. You see we've got our nuts, bolts, washers, our 2 pins, and then finally we have some finishing operations here as well. We're going to air gun spray it, mask it, and solvent cleaning. So everything you see in front of you has been done by the assembly module. You watch me do it, no interference whatsoever, and it's a real classic time saver. So if I go back to that model once more, and it's here, and that's our assembly. The one thing I didn't highlight is I go back to cost inputs, go to the assembly. So when we're in the assembly itself, we see what the different parts are. We got visual, see what's in the assembly. It points out where the fasteners are, any mating surfaces, and that's what goes into the assembly process, the mating surfaces, number of parts, etc. So that's how that's done as well. So another process is composites. So with composites in 3D, we need to tell the model what it is, what we're going to make it from. So in exactly the same way as before, we'll come to our general tab. We've told it is composites. We've told it is a hand layout solid. The process is hand layout, part size, information relating to the part, etc. And then here, we have to make assumptions, read the drawing, and manually input what we believe to be the number of full plies and then the number of drop-off plies, these here, all the way through. And then you can put in this one, you can say, well, actually, I think the percentage coverage of this is going to be 60% on average. That will change the number of drop-off plies. We can add our pill plies and so on. Once we're done, we can go, this is our process option. So we're going to cut it with ultrasonic. We're locating it with a laser. We're debulking it with reusable nylon every 4th ply. We're using an autoclave, using this material type to determine the cure cycle. Our trim length is based around the periphery of the part. That's all calculated. We don't need core machining. We will do NDT. We will do finish and heat treat, and tool fab design we'll leave off. Click on estimate, and off we go again. We'll do another estimate. So as you can see how quick this is. We've done assemblies, we've done machining, we've done sheet metal, we've done composites, etc. So here we are. We're back in SEER for manufacturing. These are the hand layer pots, our process specific. See what it is. We've got our materials, how we're going to cut it, how we're going to laser it, the orientation. If I double click, you can see how this is populated. Nine plies, ply width, what the material type is, how we're going to cut it, how we're going to locate it. The orientation is 0, covering 60% in one area, and the thickness is comes from the material type and its density. So that's what's going on in the ply table. You then do some autoclaving as part of the same process. So that's all done here. This is the process which is controlling the cycle time, operator attendance, autoclave loading, nitrogen cost, energy cost, etc. We're going to trim it. We're going to trim it on 5-axis machine, rough and finish. These are just some local parameters brought in for manipulation. NDT, so there isn't any NDT on this one. If we wanted NDT, we should have saved it as part of the environment to bring it in automatically. And there you can see sorts of things we can do. And that was the wrong one. NDT here, click on, oh, it's got water spray, sorry. So there we are, we're doing water spray. And the other ones available to you are in here. So because this is SEER for manufacturing, it covers things like Dipnico for labor cable assemblies, continuity testing, X-ray, globe penetrance, 5-axis, layout table, CMM, submerged tank, water spray, and pulse echo. So they're all in there as well. So that's available options for you. Finishing, go to process specific. We're going to hand sand it, solvent clean it, mask it, and paint it. So it's quite a comprehensive estimate from laying down the cloth, curing the cloth, trimming the part, inspecting it, and finishing it. So cradle to grave, another great estimate. It was SEER MFG and SEER 3D. So finally then, the last process is additive. So this is just the part. The processes available are binder jetting, direct energy, fused deposition modeling, liquid phase laser sintering, selective laser sintering, and stereolithography. We're using this one. You can have a mix of materials. I've added 2 in this one. It's coming from powder, information relating to the print resolution, wall thickness, trace height, support content. So we'll have a little bit of support, 12%. We're going to press it afterwards. We're going to finish and heat treatment and information relating to the part. Again, click on estimate. So the additive manufacturer has stopped. This is the first operation. So process specific, direct energy, envelope size of the part, our material, told it what we were going to mix it up with from powder. These are all information relating to the machine, its resolution, layer height, wall thickness, infill percent, support content I put in at 12, and so on. So that will then give you your detailed estimate, your setup, direct inspection and rework, material cost, etc. We're going to do a pressing op, so that's something different there, information relating to that press. Finishing operations again, abrasive blasting, solvent cleaning and air gun spraying, which is painting, and that is that one there. So that's all the processes covered in SEER for 3D. One thing I haven't showed you yet is the latest version has PMI data. So if you're fortunate enough to have this sort of information embedded into the step file, then SEER can now read this, and we're adding more and more features all the time to influence the cost based upon the tolerancing, the perpendicularness, the roundness, the tapping, all those sorts of things. So that's all in development as we speak, but we're starting, and that is here, and it's being worked upon for us. So the only other thing to mention on SEER 3D is if we come out to this one, we can batch run it. So you can run SEER 3D. What you need to do is basically tell this workbook where SEER resides, where the folder containing the step files reside, where you want to put the results, what is flexible export, where's the path to the results going to be, what's the material type, any labor rates you want to use, and so on. So it's easy to set up. Now I've got one ready here. So this is where it's pointing to. These are the parts in it. And then these are the test results here that it will come and do. Now, if I've that one in there deliberately, I've run it previously because I'm not going to do all of them. So what I will do is I'll just show you what it will look like if you ran all of them. What happens, it does an estimate for every part within that folder. And then finally, if you say yes, it will then merge all of those parts into a single line MFG workbook so that you can do analysis and report everything out to suppliers, etc., if that's what you need to do. So that should be opening shortly. There's our global parameters, and it dinged, so it's going to crash. It didn't open properly. There we go. So we'll do that then. After all, what I'll do is I will go back and run it and try doing. So if I just delete or Control X them, and we'll paste them into there because I don't want to do all the parts. I don't want to take up all of your time. Come back to the command line interface. And here we are. So we've got 3 parts in it. We've got nothing in the results, only the one file that didn't open, unfortunately. Come to here, click to run it in batch mode. And what you'll see is a little black screen pop up. There we go. And it's importing this. Now, if you imagine you've got 200 parts in there, you can go home, you can have your dinner, come back in the morning, and a great amount of work has been done already. You can then set about analyzing, reporting, presenting your results to a customer, doing bid work. And as you can see here, is imported one, it's processing one, is exporting the results out. And this little red and black splash at the background is MFG starting and stopping as it runs. So this is doing the parts. Part 1's done. Part 2 is in process. So part 2 is done. Part 3 is being importing, processing, and finally it'll export it. It does depend on the size of the part, the duration it will take. I think these are quite big parts. And once it's complete, this will just close, and then we'll be able to view the folder for the completed parts. So that's all 3 parts done. It's now merging the files together for the final MFG file where all the parts be contained. So that's the 3 parts we've done quickly as an example for you. Once that's done, this should close and we'll be able to go into the folder and see what we've managed to achieve. So just creating the last merged folder. Okay, that's finished. Let's go back. So there's our 3 parts. There's our merged file. There's our test parts. So actually, this is the merged file here. We'll try again to open it. So here we are. We have our parts all listed here. This is all of the parts. That's the ones that were done. As you can see, we have our machining ops, our finishing ops, and everything is completed as expected. Now, I opened this one on purpose because finally to just show you import export, we have this capability of exporting results. So we'll say flexible export. So we can build and create our own templates. We're going to use outsum. I'll load it to the system. That's what it's going to bring out. It's going to bring out to the clipboard by columns, including rows and column headings for the entire project. Now I don't want to output these two, so I'm going to unselect that one, export it. So let's put it onto the clipboard. So we'll come to this file here, just right click and paste. And you can see that's the name, type, part number, process, and each one of these is a result, whether it be minutes or costs. So this is the cost for all of them. And you can see basically the roll up. This line here is the total, and all the way down through for your entire report. So you have this great ability to get all this information out at the sweep of a hat. Very comprehensive, conscious of time. Just to quickly show you another couple of examples. This is a 2D estimate for a valve, full length window. There you go. You can see everything there, from purchase components, from tubes to castings to machining and so on. So it's a great comprehensive tool. If you're interested in an evaluation, please contact Cassidy for cells and the like. Contact David and Chris there for inside America and outside America. All of the details are here. Chris, David and Cassidy. Thank you very much for your time. If you need training and support, please contact us at support@gallerith.com. To have a look at all of the other wonderful tools by Gallerith, have a look at gallerith.com, whether you want software estimation, IT estimation, or whatever you need. We have something for you. Thank you very much, and we look forward to the next demonstration video.